Algebra 3, Inequalities, Type 3, Rational Inequalities. So the word rational means fraction. So when we have a rational inequality, we're going to have a fraction and our inequality sign. For example, solve 2x plus 1 over x plus 3 less than or equal to 1, where x is not equal to minus 3. So we have two things that we have to be careful of here. So our first thing is that we need to understand, well, why are they telling us this bit here? Why are they telling us that x is not equal to minus 3? Well, if I look at the denominator and I see x plus 3, well, that means if I sub in for x is minus 3, on the top I have 2 times minus 3 plus 1, and on the bottom I have minus 3 plus 3. So on the top that gives me minus 6 plus 1, which is minus 5, but on the bottom I have 0. And of course, any number divided by 0 is undefined. So therefore, that's why we're being told in the question that x is not equal to minus 3. So any number that gives the denominator a value of 0 is said to be undefined. So it's important to know that word. The second thing we have to note is that the denominator there is x plus 3. So in order for us to solve and get x on its own, we need to get rid of this fraction. So the obvious thing would be to multiply both sides across by the denominator, which is x plus 3. But the problem is we don't know the value of x plus 3. So that means that it could be positive or negative. So that's a problem, because if it's negative and we go to multiply across both sides by a negative number, then we know that that changes the inequality sign. So we have to figure out a way to deal with this. So we know that if I was to multiply across by a positive number, it doesn't change the inequality sign. So how can I be definite that x plus 3 is a positive number? Well, if I square a number, I know it is definitely positive. But of course, what I do to one side, I must do to the other. So what we're going to do is we're going to multiply both sides across by the denominator, but instead of just the denominator, we'll multiply across by the denominator squared to ensure that it is positive and therefore not change the inequality sign. So in this case, what we're going to do is multiply both sides across by the denominator x plus 3, and we're going to square x plus 3. So our equation will then become 2x plus 1 times the denominator squared, and the right-hand side is going to be 1 times the left-hand side's denominator squared. So this allows me to eliminate the denominator, because x plus 3 will go into x plus 3 squared, x plus 3 times. And therefore that leaves me with 2x plus 1 over times x plus 3. And on the right-hand side, I have 1 times x plus 3 squared. So that's going to be x squared plus 6x plus 9. So remembering that squaring our brackets, we square the first term, multiply them and double it, and square the second. So we have x by x is x squared, x by 3 is 3x, double it gives us 6x, and then 3 squared is 9. Multiplying out the left-hand side, we have 2x by x is 2x squared, 2x by 3 is 6x, 1 by x is x, and 1 by 3 is 3. And now we want to bring all our terms to the left-hand side. So we have 2x squared minus x squared is x squared. 6x plus x is 7x. And 7x minus 6x is x. And then 3 minus 9 is minus 6. So now we have our inequality. And we can see it's less than or equal to 0. So that means we're going to be looking for our answers. For x, that gives us the graph below the x-axis. We can see it's a positive x squared, so therefore we know it's going to be a U-shaped graph. But of course we need to know where does it cut the x-axis. So we need to take this quadratic and solve it to find the roots of the graph. So we have x squared plus x minus 6, and we're going to let it equal to 0 just for the sake of finding where it cuts the x-axis. So factors that multiply to give me minus 6 and add to give me plus 1 must be 3 and minus 2. So that's x squared plus 3x minus 2x minus 6 equals 0. Group the first two to get the highest common factor. So therefore that's x that's common, leaving us with x plus 3. Minus 2 is common, leaving us with x plus 3. These two brackets are the same, so if I take out the highest common factor, x plus 3, I'm left with x minus 2. Both of these multiply to give me 0, which means that one of the factors has to be 0 or both. And therefore we get x equals minus 3 and x equals 2. So again, remembering that this is an inequality, and therefore these are not my answers. But instead, if I sketch my graph, it means that it's a U-shaped graph because it's a positive x squared. It cuts the x-axis at minus 3 and 2. We're looking for the function x squared plus x minus 6, where it is less than or equal to 0. So the fact that it is less than or equal to 0 means that I am going to fill in the numbers at minus 3 and 2. Less than or equal to means where is the graph below the x-axis. So in other words, what values of x give me negative values for y? And therefore that must be every value between minus 3 and 2. So all of these x values here on the number line will give me negative y values. So that means that x has to lie between 2 and 3. Now, even though it's less than or equal to in this case, we have to make a careful note from the start, and that was, if I go back, we were told that x was not equal to minus 3. So x cannot equal minus 3, but it can be less than 3. And x can be less than or equal to 2. So it's a nice little question there, because the two inequality signs are actually different, because the minus 3 was giving us undefined, and therefore x can't be equal to it, but it can be greater than it. Okay, so x is, or minus 3 is less than x, and it can be less than or equal to 2. So the less than or equal to is coming from this sign up here, and the not equal to 3 was given to us at the start, because it makes it undefined. So go on to page 72 in active maths, and you're going to do question 11, 13, 14 and 15.